My name is Marco Palladino. I am the co-founder and CTO at Kong. And today I want to talk to you about building the modern fabric for API connectivity. Software is eating the world, and the APIs are eating software. When we look at what anybody's building today, APIs are the backbone of our digital world. In the day-to-day, finance, healthcare, travel, consumer, APIs are powering all these digital experiences across the board. Now, if APIs become the most important asset of our application, we must support the underlying API infrastructure the proper way. When APIs go down, our applications go down. APIs went through a journey. APIs is not a new concept, of course, and over time, we had different ways of building systems with different API technologies. But in 2009, in 2013 and 2014, there were like two inflection points in our adoption of APIs. First, the iPhone gets released in 2007, Steve Jobs goes on stage, new iPhone, everybody now builds mobile applications that need to be available in the App Store. The mobile trend was quite big, of course, and everybody builds an API as an add-on, as an afterthought, on top of our monoliths in order to be able to create these mobile experiences. And then, in 2013, Docker comes out. In 2014, Kubernetes comes out. And everybody now has a self-service way to provision underlying infrastructure that allows us to transition monolithic applications to microservices without having to build every piece of that infrastructure from scratch. Microservices is not a new concept, and microservices for sure were not invented with Docker and Kubernetes. Organizations like Google, like Netflix, like Amazon, they did transition to microservices before 2013 and 2014. To do that, they had to build their own tooling from scratch. What Kubernetes and the Kubernetes ecosystem gave us is a self-service way to get access to these technologies without having to build them from scratch. So now every enterprise organization in the world can think about deploying microservices and APIs. The transition from monolithic applications to microservices is a transition that has exponentially increased the number of APIs that we're running in our systems. APIs are not being consumed only for external consumption, for mobile, for partners, for an ecosystem of developers. APIs are being consumed more and more internally across our applications, but even within the applications themselves. We're doing this because, of course, we have learned that monolithic applications don't really scale after a certain point. And so it's better to transition them to microservices. We can build more reliable systems. If somebody builds anything in the monolith and the monolith goes down, the whole experience goes down. With microservices, of course, we can create better business outcomes because we can compartmentalize our functions, our services, and different teams can work on them with less coordination needed as long as there is an API that allows these services to communicate with each other. We can build new products and new applications in a faster way. We can reuse and compose our APIs as if it was an assembly line, the assembly line of software. We pick APIs that we want to use to access data and services and ship new products. That allows us to improve our developer efficiency. It lowers the time to market for new products and even new experiments that the business may want to take. And then, of course, we can scale in a much better way, in a much more efficient way. With microservices, we don't have to scale the whole infrastructure all the time, but we can only scale the parts of our application that need to be improved, that need to be scaled, therefore reducing our overall infrastructure cost. These are just some of the business outcomes that we want to achieve when we transition to microservices. And so to really understand why this is important in the context of APIs, it is because this transition is incentivizing the creation of more APIs and more microservices. We are just at the beginning of this journey. When we look at the next 5 to 10 years, we're going to be having more applications, not less. And if applications are built on top of APIs, we're going to be having more APIs, more microservices, not less. Today, we have to think in the organization, what is the underlying infrastructure that we are going to be providing to our teams in such a way that we can incentivize this type of growth and we can support this type of infrastructure over time Choosing the wrong technologies at this stage is going to be preventing this vision from being executed. We need to enable this vision with the right tooling and the right platforms in place. It's a very critical decision. It's the make it or break it of our IT vision for the next 5 years. And so to really understand the journey that brings us to this new fabric for supporting all of these APIs, we really have to go and look at the journey that we are doing in our systems to understand what are all the moving parts that we need to support. In a monolithic application, we have lots of requests going to the monolith. Like I said, APIs used to be an afterthought. In microservices, APIs are not an afterthought. APIs are there since day one. APIs are needed and required. In a monolith, we have all these clients consuming our monolith, and as we decouple the monolith, we have a lot more traffic that is happening within both external clients and internal clients. The traffic increases exponentially. Therefore, performance becomes a bigger concern with microservices. We want to make sure that, performance was always a concern, but at the edge, we could fix that by putting a CDN in front of our APIs and calling it a day. With microservices and with this new world built by APIs, we need to have the lowest latency we can possibly get, because that latency compounds over time, because there is a lot much more back and forth across all the services that we are creating that are communicating with each other. In order to simplify access to our services, of course, this is madness. We cannot manage this. In order to simplify access to our services, we need to be able to provide a standardized way to expose the APIs that we want other teams or other partners to consume through an API gateway. Think of the API gateway as the nice storefront that allows us to pick the APIs that we want to expose and create a nice onboarding experience, being able to manage the consumption of those APIs, being able to create tiers, and treat an API as a product with a product life cycle. Products are going to be created. There's going to be new versions of products. We're going to be decommissioning old versions of our products. And all of that entire product life cycle needs to be translated into an API life cycle. How do we create new APIs? How do we create new versions of those APIs? How do we manage access to those APIs? How do we rate limit? How do we protect these APIs? And how do we decommission the APIs when we want to create a new version? APIs are a product, and what API management does is giving us the right tooling to treat those APIs as a product. Now, of course, that's only one side of the picture. What about all that traffic inside of our applications? As we transition from monolithic to microservices, we have a lot of traffic that's happening within the applications themselves. In a monolith, we don't have that. In a monolith, we have function calls on the CPU, right? Whereas with microservices, we are replacing the reliability of the CPU with the unreliability of the network. The network is by default not secure. By default, it's not observable. By default, it's not reliable. And if the network is not secure, not reliable, and not observable, that means that our applications are not reliable. And if the applications are not reliable, our customer experience is going to be unreliable, which means that we're going to have poor customer retention. By improving the network, we make our applications better, and therefore, we make the overall business better. API protocols also have shifted a lot over the past few years. It's not just about REST anymore. It's not just about, we used to run SOAP, then REST. It's about using whatever it's the best tool for the job. We see the adoption of gRPC. We see the adoption of event-based architectures with log collectors like Kafka, for example. We also see the adoption of GraphQL, new ways to access information and APIs in this new microservices world. So in order to simplify that internal traffic, we must do something. Now, the gateway can be used for external traffic, but also for internal traffic. So the gateway allows us to create that nicely curated experience for both internal and external consumption. But for that internal traffic, we must apply something else. That something else could be service mesh. Service mesh allows us to essentially remove the cross-cutting concerns of managing the network in a secure, reliable, and observable way, moves that away from the services themselves and into the underlying infrastructure. With or without a service mesh, we still have that connectivity going on. And so if it's not a service mesh providing us this feature set, then the teams are building that feature set when they build their services. This lowers their efficiency. When they focus on building a service, they should be focusing on creating the products and the customers and the user experience. They should not be focused on building the underlying infrastructure. And without a service mesh, our teams are building the underlying infrastructure because they're writing code to manage this unreliable network within the services themselves. With service mesh, we can transition the teams from being the builders of API connectivity management into being the consumers of API connectivity management. And that concern moves to the platform team, the team that's supporting the application teams in anything that they're doing. Service mesh, therefore, is an opportunity for us. It's an opportunity to not only build better applications, but it's also an opportunity to make our services smaller, because now all of these cross-cutting concerns move away from the services. In a service mesh, anything that can make or receive a request is a service. So in a service mesh, the gateway is a service, because the gateway can receive requests and then make requests to another service. The service mesh is this network overlay where everything runs, the services that we create and the technologies that we adopt. Databases or caches or Redis, for example, all of those are services in a service mesh. Now, of course, we have many services. We want to choose the subset of services that we want to expose via an API experience, and we can use the gateway to manage that control. So in a way, service mesh, it's a much lower level concern, right? We build this underlying networking at the bottom that supports all the APIs that we create. And then on top of that, we're going to be running that curated experience through the gateway. Now, the value of a microservice-oriented architecture is being driven by the consumption of our microservices. We could have 1 million microservices, and if none of them gets any usage, those microservices are useless. The adoption of the microservices in the organization drives the value of our microservices architecture. And that's why another component that's becoming very important when thinking about our overall architecture and the future of the infrastructure that we're building is also that API design, testing, and collaboration component. What are we doing to make it easier for the teams, the humans that are going to be consuming these microservices? What are we making to make it easier for them to explore what microservices are available in the organization? What are we doing to incentivize the testing and the usage and proper creation of these APIs? And that is a whole area that is going to be driving success on top of these underlying API infrastructure. It's full stack. It starts from API design and testing. We want to build them in a consistent way, cataloging the APIs, making them available. I call it human service discovery. When we think of service discovery, we usually think of machine service discovery. But that's a different type of service discovery. That's the human service discovery, making sure that those APIs are visible to the teams so that the teams can make a conscious decision to build them and use these APIs in the assembly line, so to speak. Going through the gateway for internal and external traffic. The gateway is an extra hop in the network, right? But that extra hop, it's worthwhile if we can get the benefits of managing the API lifecycle. And then the service mesh, which does not imply an extra hop in the network because performance, it's very important. It removes that extra hop in the network, and it allows us to connect point to point these services in this underlying fabric. When the monolith was down, the application was down. But in a microservices-oriented architecture, when microservices are slow, the application is down. Slow is the new down. We have to be fast, we have to be quick. Of course, I'm the CTO of Kong, right? So this is our bread and butter. We provide a full stack that covers each one of these different areas with different products that are working very well together. And we're working with more than 500 enterprise organizations to provide this underlying infrastructure. All right, modern API architectures have evolved. So we're going from classic, traditional monolithic applications and architectures where API was an afterthought. API management used to be hard to use, used to be hard to scale. And we're moving towards a distributed, decentralized architecture where the gateways and the underlying technologies that we're providing are easy to use, they're easy to deploy, they're single cloud, multi-cloud, they can also support hybrid environments. And then we want to be able, of course, to support multi-cloud. We don't want to run different API infrastructure across different clouds. Rather, we want to have some consistency in such a way that our API infrastructure behaves the same way. And if APIs really becomes the most critical asset in our organization, we want to make sure that we do that the right way. And so technology that can be portable, it's very important. And then finally, we transition to a full service connectivity architecture, which allows us to create that full stack, north-south, east-west, with API management and service mesh together, so that we can cover connectivity inside the applications with the mesh, and yet at the same time, we have the right tooling to be able to expose these APIs as a product to internal teams or external customers. So there are three suggestions that I recommend following when thinking about building this underlying infrastructure. First and foremost, open source has been the biggest driver of this microservices transformation that we're seeing in the world. This is bottom-up transformation. This is driven by teams having access to self-service software that they have control on. If APIs are really the system of record of each piece of information that we have in the organization, and if APIs are the system of record of each function that we can execute in our organization, then APIs become the brain and the spine of the organization. We don't want to run a black box for the brain and spine of the organization. We want to be able to run software that we can control, software that we have visibility in. And so open source gives us that visibility, gives us that extensibility. Open source also creates a much better feedback loop. And when we think about Docker, Kubernetes, Kafka, even Kong, all the tooling that Kong provides, when we think about Elastic, open source is the underlying keyword for each one of these technologies. No black box, extensible if you want to expand it. It's battle tested because we can take advantage of what the community and the adoption is doing to fix bugs even before they show up in other deployments, as well as it's a transferable skill set. If I am an architect working for an organization and I adopt open source software to run my infrastructure, if I were to move and change to a different organization, that skill set is being transferred with me because open source is self-service, right? I can adopt it elsewhere. Agnostic, we want to be able to support our teams in any platform or underlying technology they may want to use for their APIs. Some teams are going to be using events for building asynchronous APIs. Some teams are going to be using synchronous APIs with gRPC, for example. We want to be able to support our teams at every stage of their journey. Some of them are still running on virtual machines, and some of them are transitioning to the cloud, and some of them will be transitioning to Kubernetes. The underlying API infrastructure that we're building doesn't have to be specific for VMs or Kubernetes or containers. A proper infrastructure with the proper technology can support all of these different platforms in the same way. Platform agnosticity and multi-cloud support becomes essential so that we have a consistent way of managing the most important asset in the enterprise, APIs. And then finally, we have to think about the full stack. Right? There is going to be different connectivity types in our applications. There is going to be connectivity that we want to expose at the edge, to mobile apps, to developers, to partners. There is going to be connectivity inside the organization across all the applications that we're building. And there's going to be connectivity within the applications themselves whenever these applications are being transitioned to microservices. So 3 different types of connectivity with 3 different business outcomes that we need to support with the right technology. And so being able to provide that full stack that we've just seen from gateway to service mesh is going to be important because then we can support our teams throughout the entire API journey, not just part of it. Well, this was a very short presentation that gives an insight about some of the changes that are happening in our API world. KongHQ.com if you want to learn more about Kong, and you can find me online if you have any questions. By the way, we can open up a small Q&A session here if you have questions right now.
Okay, I have a mic, so if someone has a question, I'd be happy to share. Question? Yes. So when you say connectivity to different things, right? Service mesh versus your traditional applications, is there any difference in how the gateway should behave or tackle that connectivity? Should it be connecting to the service mesh a little different, monitoring something different versus the regular application?
Yep, no, this is a very good question. The gateway technology can be used in two different ways, right? Gateway technology can be used as a router, right? We have many, developers that are thinking of gateway as an ingress router into the cluster, or the gateway technology can be thought of covering what I call the L8 capabilities. So the user interaction with the APIs and the developer interaction with the API. Now, if the gateway is being used primarily as an ingress router, sure, we don't really need it, right? Because we can just open up a port on the service mesh and enable that traffic to flow. But that's probably the wrong way to use the gateway. The right way to use the gateway is to enforce a life cycle on top of those APIs, not just as an ingress, not just as a router. Now, it's very important that the gateway technology and the mesh technology can work together in a seamless way, because essentially they are dedicated to different areas of the connectivity lifecycle and yet on the same platform. So we want to be able to deploy a service mesh for all the internal traffic. In a service mesh, services are one-to-one, so we expose everything that's running in the mesh. We cannot expose that to a customer that wants to build against our API. And so we can use the gateway to choose the subset of services and APIs that we want to package as a product and then offer that to a partner, a developer, a customer, and so on and so forth. And then use the gateway to manage backwards compatibility changes whenever some of these APIs were to change. Our developers in the service mesh are going to be deploying quite rapidly new versions of the API, new breaking changes. When we have a front-facing API to a customer, we want to make sure that whatever change happens under the hood is it's backwards compatible with whatever client the customer has built on top of our APIs. So we're sort of exiting, at this point, the service mesh world and entering this new world, which is about, again, managing APIs as a product. I think that API gateways have to fulfill this role, whereas the service meshes can be the underlying infrastructure for all of these APIs and services internally whenever the teams build anything. Now, the gateway is a service in the service mesh in this scenario, because, like I said, every service makes anything that can make or receive a request is a service. Therefore, the gateway will receive requests and makes requests is a service. Now, another area that I want to double-click is the deployment patterns, right? With service mesh, typically, we have a sidecar deployed next to each service. And the sidecar, if we want security to be enforced end-to-end, that sidecar also needs to be deployed on the clients, right? Because then the originating request is being captured by that sidecar on the client side, encrypted, given an identity, and then moved into the mesh. Sometimes that is not possible. Sometimes we cannot deploy a sidecar in a mobile app. We cannot deploy a sidecar in a partner application. We have no control on how they're building their software. And so we want to give them an ingress that does all those things we just mentioned, and also that ingress is being in charge of implementing complex authentication or authorization rules on those incoming connections. Again, this is more of an API management concern rather than a service mesh concern. Service mesh is, I'm going from A to B. How do I make sure that from A to B, I'm secured, I have an identity, it's observable, it's routable, it's working, and then the L8 concern, which is the user interaction with the API, that's API management.
We have one more question here.
Hey, Marco, how are you? I was wondering if you could provide guidance on how to right-size a mesh, either operationally. Do you favor, generally speaking, more prolific, smaller meshes, fewer, larger ones, and how does that influence sizing of your gateway fleet?
The value of a mesh is being driven by the amount of services that we're running in the mesh. So, of course, the more services we have in a mesh and the more value we get out of that mesh. At the same time, we don't want to introduce too much coordination among different teams and different applications, because we don't want to end up in a situation where one team can apply a routing policy that somehow breaks another application. So my suggestion is to adopt multi-mesh, service mesh technologies, which means that we can provision a virtual mesh, a folder to each application, to each team. The policies, the service mesh policies that we apply for one mesh are completely isolated from the service mesh policies that another team may apply in their own mesh. Now, if we do that, the next question is fine, but then how do we enable cross-mesh communication? Well, a proper service mesh should do that. I mean, at Kong, we're involved with Kong Mesh and Kuma that has been donated to CNCF. It ships with a built-in cross-mesh communication. So we could be providing a mesh for each application that's compartmentalized. The team can do whatever they want in there, and then still provide cross-mesh communication natively by leveraging the service mesh capabilities. Having one large mesh for the entire organization, probably it's the wrong thing to do, because there's going to be a lot more coordination required in that case.
Okay, thank you.
Thank you.
I know there are more questions for Marco. A little applause for Marco. I know there's some more questions. We just ran out of time. Sorry, I wasn't here to start.